Hello friends, welcome to my lecture on negative binomial distribution and Poisson distribution. First we discuss negative binomial distribution. Suppose we perform Bernoulli trials where P is the probability of success in every trial. Instead of fixing the number of trials, let us assume that the trials are performed until R successes are obtained. Okay? The number of trials are not fixed in advance. We wish to find the probability that we require exactly n trials. Then the nth trial must produce rth success and the remaining r minus 1 successes should come in the previous n minus 1 trials. This means that we go on performing trials until we get the rth success. As soon as we get the rth success, we stop the trials. So, let us say n number of trials are performed to get the exactly r successes. Then rth success will come in the nth trial and n r minus 1 successes should come in the previous n minus 1 trials. Hence, the required probability is that n minus 1 c r minus 1 p to the power r minus 1 q to the power n minus 1 minus r minus 1 by binomial distribution, because r minus 1 success are obtained from n minus 1 trials. So, the probability for that will be n minus 1 c r minus 1 p to the power r minus 1 q to the power n minus 1 minus r minus 1, and rth success comes in the nth trial. The probability for that is p. Okay. So, the probability that exactly r successes are obtained in n trials where rth success comes in the nth trial is given by this expression, and this can be written as n minus 1 c r minus 1 p to the power r q to the power n minus r. N will take values from r onwards, r plus 1 and so on. Now, this is called the inverse binomial formula. Okay. The formula that we have obtained, okay, this formula is called as the inverse binomial formula, or we also call it as negative binomial formula. Let x be the number of trials required till the rth success. Okay. Let x be the random variable x be denote the number of trials required till the rth success. Then probability that x is equal to n is n minus 1 c r minus 1 p to the power r q to the power n minus r, as we have just now seen, and n minimum value of n will be of course r, because to get r successes in n trials n cannot be less than r. Okay. So, n will be greater than or equal to r. So, n is equal to r plus 1 and so on. This is known as inverse binomial distribution, or we also call it as negative binomial distribution. It is also known as Pascal distribution. Okay. If you in particular, if you take r equal to 1, then you can see p x equal to n is equal to n minus 1 c 0 p to the power 1 q to the power n minus 1, n minus 1 c 0 is equal to 1. So, we get p q to the power n minus 1. That means, in n minus 1 trials we do not get any success, we get failures every time. So, the probability is q to the power n minus 1. In the nth trial we get the success, so the probability for that is p, and therefore, it is p q to the power n minus 1. This distribution is called as geometric distribution. Now, let us discuss the mean and variance of the negative binomial distribution. Okay. So, mean or you can say expected value of the random variable x, okay, is equal to let us say sigma x equal to r to infinity, because suppose x trials are performed, okay, to get the r successes where rth success comes in the xth trial. Okay. Then we have sigma x equal to r to infinity, okay, x into probability that x is equal to x. Okay. So, this is sigma x equal to r to infinity x times probability that x is equal to x. Okay. Instead of n here I am taking x. So, probability x equal to x is x minus 1 c r minus 1 p to the power r q to the power x minus r. Okay. So, we have x minus 1 c r minus 1 p to the power r q to the power n minus r, and then x is there, right. So, we can write it as this is x minus r. Okay. Yeah. So, we can write it as, now let us multiply and divide by r. Okay. Then we can write it as this x can be absorbed in x minus 1 factorial. We can write it as x factorial. We have multiplied by r and divided by r. So, r into r minus 1 factorial gives r factorial. Then we have x minus r factorial, and we get p to the power r q to the power x minus r. Now, this is equal to r into p to the power r is independent of x. So, we can write it outside, sigma x equal to r to infinity x c r q to the power x minus r. Okay. Now, this is what r times p to the power r. If you expand this, when you put x equal to r, r c r is 1, okay, then q to the power r minus r, so q to the power 0, that is 1. So, 1, then we have x r x equal to r plus 1, so r plus 1 c r, that means r plus 1 c r times q to the power r plus 1 minus r, so q, then we have next term r plus 1 r plus 2, when x is r plus 2, we get r plus 2 c r, okay, q to the power 2, then r plus 3, okay, c r q to the power 3, and so on. Okay. Or we can also write it as r into p to the power r 1 plus r plus 1 c r plus 1 c 1 q, then r plus 2 c 2 q square r plus 3 c 3 q q, and so on. Okay. Now, this is nothing but r times p to the power r 1 minus q to the power minus r plus 1. Okay. This is the binomial series, okay, for this for the expression 1 minus q to the power minus r plus 1. Okay. And this is valid because q is lying between 0 and 1. P is greater than 0, okay. We are taking p to be greater than 0 here. So, q is between 0 and 1, okay, and therefore, this binomial series can binomial expansion can be written as 1 minus q to the power minus r plus 1. Now, 1 minus q is equal to p, okay. So, we have r to the power r times p to the power r into p to the power minus r plus 1, which is equal to r by p. Okay. So, mean of the negative binomial distribution is given by r over p. Now, let us find the variance. Okay. So, to get the variance, we determine E x square. Okay. So, variance is equal to E x square minus E x whole square. Okay. So, E x we have already found, it is r by p, we just need to find E x square. Okay. So, E x square similarly can be written as sigma x equal to r to infinity x square p x equal to r, p x equal to x. Okay. So, this is sigma x equal to r to infinity, and x square let us write as x into x minus 1 plus x. Okay. X into x minus 1 plus x, and then we have okay, we should write it as x into x plus 1 minus x. Okay. X into x plus 1 minus x. Okay. Now, p x equal to x is n minus 1 c this is instead of n it is x. So, x minus 1 C r minus 1 p to the power r q to the power x minus r. Okay. X minus 1 C r minus 1 p to the power r q to the power x minus r. Now, let us write it in as sum of two terms, sigma x equal to r to infinity x into x plus 1 x minus 1 factorial divided by r minus 1 factorial x minus r factorial, then we have p to the power r q to the power x minus r, and the second term is for this x. So, sigma x equal to r to infinity x x minus 1 C r minus 1 p to the power r q to the power x minus r. Now, what will happen is this x plus 1 into x can be absorbed in x minus 1 factorial, and we will have x plus 1 factorial. Okay. And this r minus 1 factorial we can make it as an r plus 1 factorial by multiplying and divide by r plus 1 and r. Okay. So, we multiply by r and r plus 1 and divide by r and r plus 1, and then I write it as sigma x equal to r to infinity x into x plus 1. When you multiply to x minus 1 factorial, it becomes x plus 1 factorial. R into r plus 1 you multiply in the denominator, it becomes r plus 1 factorial, and this is x minus r factorial. So, I will write it as x plus 1 C r plus 1. Okay. It can be written like this, and then p to the power r q to the power x minus r. Okay. This is nothing but expectation of x. Okay. So, I can write it as expectation of x. We do not have to calculate this, we have already determined its value is r over p. Okay. Now, here what do we get? P to the power r again is independent of x. So, I write it r into r plus 1 p to the power r. Okay. And then we have sigma x equal to r to infinity x plus 1 C r plus 1 q to the power x minus r minus r by p, the value of x. Okay. Now, this is r into r plus 1 p to the power r. Let us expand this sum. So, put x equal to r, but we get r plus 1 C r plus 1, that is 1, and then q to the power r minus r, that is equal to 1. So, we have 1, then q x equal to r plus 1. So, you get r plus 2 C r plus 1, r plus 2 C r plus 1, and we get q to the power r plus 1 minus r. So, q, then r plus 3 C r plus 1, okay, q square, then r plus 4 C r plus 1 q and so on, okay, minus r by p. Now, NCR we know, NCR is NC n minus r. So, r plus 2 C r plus 1 will be r plus 2 C 1, this is r plus 3 C 1, this is r plus 4 C 1, no, this is r plus 1 p to the power r 1 plus r plus 2 C 1 q, then r plus 3 C 2 q square, then r plus 4 C 3 q and so on, okay, minus r by p. So, this is r into r plus 1 p to the power r, and this is 1 minus q to the power minus r plus 2, okay, minus r by p. This is binomial expansion of 1 minus q to the power minus r plus 2, because q is lying between 0 and 1. So, it is valid. Now, this is r into r plus 1 p to the power r q to the power p to the power minus r minus 2 minus r by p, okay, p is 1 minus q. So, p to the power r gets cancelled with p to the power minus r, and what we get, r into r plus 1 divided by p square minus r by p. So, this is the value of E x square. Okay. Hence, variance of x is equal to E x square minus Ex whole square is equal to R into R plus 1 divided by P square minus R by P, that is the value of Ex square, minus Ex is R by P. So, R by P whole square. So, R square by P square. Okay. Now, we multiply R to R plus 1, we get R square plus R. So, R square by P square plus R by P square minus R by P minus R square by P square. So, this gets cancelled with this, and what we get here, let us take out R by P square, then we get 1 minus P. Okay. Yeah. So, R into, so variance of X is equal to, okay, R by P square times 1 minus P. Okay. So, this is the variance, okay, R into 1 minus P divided by P square. Now, let us take some examples. An oil company conducts a geological study that indicates that an exploratory oil well should have 20% chance of striking oil. So, P is here 1 by 5, 20% means 1 by 5. What is the probability that first strike comes on the third well drilled? Okay. So, we know that probability that X equal to X is equal to X minus 1 C R minus 1 P to the power R Q to the power X minus R, okay, where X is the number of wells drilled. Okay. So, we want that the first strike should come in the third well drilled. That means, we need to find the probability of P x equal to 3. Okay. In the third well, we should get the first success. So, we get 3 minus 1, X is R is equal to 1. So, 1 minus 1, P to the power 1, Q to the power 3 minus 1. Okay. So, this is 2C0, that is means 1, we get P times Q square. Okay. P is equal to 1 by 5, Q is equal to 4 by 5. So, 4 by 5 square. Okay. So, what we get is, you can say this is 0.20, okay, 1 by 5 is 0.20 and a 4 by 5 is 0.80. Okay. So, 0.80 square into 0.20 is 0.128. Okay. This is the first part. What is the probability that third strike comes on the 7th well drilled? That means, we get the third success at the 7th well. Okay. So, we get probability that X equal to 7 and R equal to 3. Okay. So, we get 7 minus 1, 3 minus 1, okay, P to the power 3, Q to the power 7 minus 3. Okay. So, this is 6C2 P cube Q to the power 4. Okay. 6C2 is 15, P cube means 0.20 raised to the power 3, okay. Q means 0.80 raised to the power 4. Okay. So, 15 into 0.20 to the power 3 and 0.80 to the power 4. So, this is 0.049. Okay. So, this is the answer. Okay. Now, what is the mean and variance of the number of wells that must be drilled if the oil company wants to set 3 producing well? Okay. So, here we are given R equal to 3 producing well we want, okay, and for the 3 producing well, what is the mean and variance of the number of wells that must be drilled? Okay. So, we have just now found mean of X, mean of the random variable X. Okay. This is equal to R by P. Okay. R is equal to 3 because we want 3 producing well, 3 divided by 0.20, that means 3 into 1 by 5. Okay. This is 3 divided by 1 by 5, that 3 into 5. Okay. So, this is 15. Okay. So, mean is 15 and variance of x is equal to r into 1 minus p divided by p square. Okay. So, we get we get 3 1 minus 0.20 divided by 0.020 raised to the power 3. So, this is 3 into 0.80 divided by 0.20 raised to the power 3. Okay. We can write it as 3 into 0.80 is 4 by 5, okay, and 0.20 is 1 by 5. So, 5 cube. So, 5 into 5 into 5. Okay. So, what we get here 5 into 5 is 25, 25 into 4 is 100, okay, means 3 multiplied by 3. Okay. So, this is r into 1 minus p divided by p square. Oh, it is it is not cube, it is square. Okay. So, we have to delete 1 5, okay, and then this is 60. Okay. So, r into 1 minus p over p square is 3 into 1 minus 0.20 divided by 0.20 raised to the power 2, and we get 3 into 0.80 divided by 0.20 to the power 2 equal to 3 into 4 by 5 into 5 into 5, that is 60. Okay. So, mean is 15, okay, and variance is 60. That means, on an average 15 wells need to be drilled, okay, in order to have 3 producing wells. Okay. So, this is the question number 1. Let us go to question number 2. A large lot of tires contains 5% defectives. Okay. So, 5% defectives are there, 4 tires are to be chosen for a car. Find the probability that we find 2 defective tires before 4 good ones. That means, the 4th good tire must come in the 6th trial. Okay. So, we have here n equal to 6 and p equal to 0.95, okay, because it contains 5% defectives. So, the probability of a defective tire is 0.05 and probability of a good tire is 0.95. This is the probability of a good tire. And we need to have 2 defective tires before we get 4 good ones. That means, when we pick the tires, okay, we should have 2 defectives before having the 4th good one. Okay. That means, 2 defective and 4 good tires means 6. So, 6th trial at the 6th trial we shall have the good tire. So, this is probability required probability is 6 minus 1, okay, x minus 1, c r minus 1, r minus 1 means we have 4 good tires. Okay. So, 4 minus 1, okay, and then p to the power 4, q to the power 2. Okay. So, we have 5 c 3, okay, and p to the power 4 means 0.95 to the power 4, q to the power 2 means 0.05 to the power 2. Okay. 5 c 3 is equal to 5 c 2 and 5 c 2 is 5 into 4 divided by 2. So, that is 10. Okay. So, 10 into 0.95 raised to the power 4 into 0.05 raised to the power 2. When you multiply this, it comes out to be 0.02036. Okay. Now, mean is equal to r by p. Okay. So, find the mean and variance of the number of defective tires before you find 4 good tires. Okay. So, mean and variance of the number of defective tires before you find good tires, 4 good tires. Okay. So, this is 4 by p. Okay. P is equal to 0.95. Okay. So, 4 by 0.95 means 4 into 100 by 95. So, that is 80 by 19. Okay. And then we have variance equal to r into 1 minus p divided by p square. So, this is r is equal to 4, 1 minus p is 1 minus 0.95 divided by 0.95 square. So, this comes out to be 4 into 0.05 over 0.95 square. So, this is equal to 80 by 361. Okay. This is equal to 80 by 361. Okay. Now, let us go to Poisson distribution. Poisson distribution is a discrete probability distribution of a discrete random variable, okay, say x. It is named after the French mathematician S. D. Poisson. It is defined for non-negative values of x as follows. The probability that x takes the value x is lambda to the power x into e to the power minus lambda divided by x factorial, and x takes the values 0, 1, 2, 3 and so on. Lambda greater than 0 is a parameter of the distribution. Okay. So, for the distribution we need to know the value of x and lambda, okay. Then we get the probability of x equal to x. This distribution is suitable for rare events for which the probability of success or the probability of occurrence p is very small and the number of trials n is very large. So, we apply it on in those cases it is very useful in those cases where number of trials n is very large and p is very small. In those cases if you apply the binomial distribution to calculate the probability, there is a lot of difficulty. It becomes very cumbersome calculation because n is large and p is small. So, calculating the probabilities is very laborious. So, we apply this Poisson distribution. It is an approximation to the binomial distribution and it works very nicely when n is very large and p is very small. So, the examples of rare events are a number of printing mistakes per page made by a good typist, okay, number of accidents on a highway, number of defectives in a production center, okay, number of telephone calls during a particular odd time, okay, during the night, like for example or early morning, the number of telephone calls are very less in comparison to the during the day. So, number of telephone calls during a particular odd time, number of bad dishonored checks, okay, at a bank, okay. So, dishonored checks is a very rare event, okay. And while the number of honored checks is very large. So, n is very large and p is very small. It is obtained as a limiting case. The Poisson distribution we shall see now is obtained as a limiting case of the binomial distribution. Let us see how we get it. Okay. The probability of x successes in n Bernoulli trials with probability of success as p, okay, is given by Bxnp. Bxnp denote the probability of success in probability that x is equal to x, probability of x successes in n trials. So, Ncx p to the power x q to the power n minus x, where q is equal to 1 minus p and x takes the values 0, 1, 2, 3 and so on up to n. Okay. Now, when n is large and p is small such that n p equal to lambda is of a moderate size, okay, then let us see what happens to this Bxnp. Bxnp is can be written as n factorial over x factorial n minus x factorial, and p can be written as n lambda by n, okay, p n p equal to lambda gives lambda p equal to lambda by n. So, lambda by n to the power x, and q is 1 minus p. So, 1 minus lambda by n to the power n minus x, and this n factorial divided by n minus x factorial, this gives you n into n minus 1, n minus 2, n minus x minus 1, remaining factors get cancelled with n minus x factorial. So, n into n minus 1, n minus 2, n minus x minus 1 divided by x factorial, okay, into lambda to the power x over n to the power x 1 minus lambda by n to the power n minus x. Now, let us see, when we take the limit as n goes to infinity, this Bxnp tends to lambda to the power x into e to the power minus lambda divided by x factorial. How that we get that? So, this n to the power x you can divide, these are n factors, okay, 1, 2, 3, 4 and so on up to x factor. So, n to the power x we can divide here, and this is equal to we can do it here, bx and p, this is equal to we can write as 1 minus 1 by n, 1 minus 2 by n, 1 minus x minus 1 by n divided by x factorial, then lambda to the power x, and then 1 minus lambda by n to the power n minus x. Okay. Now, this is equal to, this can be written further as now as n goes to infinity, okay, bx and p goes to, this will go to 1, this will go to 1, this will go to 1. So, we will have 1 by x factorial, then lambda to the power x, it is independent of n, then 1 minus lambda by n to the power n will go to e to the power minus lambda. We know that limit of 1 minus lambda by n raised to the power n as n goes to infinity is e to the power minus lambda. So, this will go to e to the power minus lambda, and 1 minus lambda by n to the power minus x will go to 1. Okay. So, we get lambda to the power x e to the power minus lambda divided by x factorial. Okay. So, as n goes to infinity, the bx and p goes to, this goes to lambda to the power x into e to the power minus lambda divided by x factorial. So, when n is very large and p is very small, the Poisson distribution is a good approximation of binomial distribution. Now, it has mean lambda, let us show that it has mean lambda and its variance is also lambda. So, in the case of Poisson distribution, it turns out that mean and variance are same. Okay. So, mean is equal to E x equal to sigma x varies from 0 to infinity. Okay. X here takes values from 0 to infinity. So, x into probability that x equal to x. Okay. The random variable x here, which is Poisson distributed, takes values from in the case of binomial distribution, x takes the value 0, 1, 2 and so on up to n. Now, n is going to infinity. So, x takes the values 0, 1, 2, 3 and so on up to infinity. So, x into lambda to the power x e to the power minus lambda divided by x factorial, and x varies from 0 to infinity. E to the power minus lambda we can write outside, okay, because it is independent of x, and then here first term becomes 0 because when x is 0, this first term gives us 0. So, x varies from 1 to infinity, okay, x into lambda to the power x divided by x factorial, and this x I can cancel with one x here in the x factorial, and I get e to the power minus lambda sigma x equal to 1 to infinity lambda to the power x divided by x minus 1 factorial. Now, let us take x minus 1 equal to j. Okay. So, then it is equal to sigma over it is equal to e to the power minus lambda sigma over j equal to 0 to infinity, okay, lambda to the power x is equal to now j plus 1 divided by j factorial, okay, when x is 1, j is 0. Now, this is, and when x is infinity, j is infinity. So, lambda to the power j plus 1, we can take 1 lambda from here. So, lambda times e to the power minus lambda sigma j equal to 0 to infinity lambda to the power j divided by j factorial. Now, this quantity is e to the power lambda, okay. So, lambda e to the power minus lambda into e to the power lambda, and we get lambda, okay. So, mean comes out to be lambda like this. Okay. Now, let us show that variance is also lambda. Okay. So, to show that variance is lambda, let us write variance equal of x equal to E x square minus E x whole square. Okay. So, we need to E x we have already found, it is lambda, we need to find E x square. So, E x square equal to sigma x equal to 0 to infinity x square into e to the power minus lambda, lambda to the power x by x factorial. We can write it as first term is 0. So, we can write it as sigma x equal to 0 to infinity x into x minus 1 plus x. Okay. X square, let us write it x into x minus 1 plus x, e to the power minus lambda, lambda to the power x divided by x factorial. Then we can write it as sum of two terms. So, sigma x equal to 0 to infinity x into x minus 1 e to the power minus lambda into lambda square into lambda to the power x divided by x factorial, and the second term sigma x equal to 0 to infinity x into e to the power minus lambda, lambda to the power x over x factorial is expectation of x, which we have already got. Okay. So, this is now x into x minus 1, we can cancel with x into x minus 1 in x factorial, and then we get here x runs from 2 to infinity, because when x equal to 0 or x equal to 1, this term becomes 0. Okay. So, e to the power minus lambda, lambda to the power x divided by x minus 2 factorial we get. Okay. Now, putting x minus 2 equal to j, let us put x minus 2 equal to j, then this is sigma j equal to 0 to infinity e to the power minus lambda, lambda to the power j plus 2 divided by j factorial, and we get this as j square lambda square, let us take common, then lambda square e to the power minus lambda into sigma j equal to 0 to infinity lambda to the power j over j factorial is e to the power lambda, and here E x is we have already found lambda. Okay. So, what we get is lambda square plus lambda we get. Okay. Now, variance of x we can find. So, E x square is lambda square plus lambda, E x whole square is lambda whole square, and we get variance as lambda. This cancels with this. Okay. So, in the case of Poisson distribution, the mean and variance are same. Now, let us go to this problem. Let x be the number of cars per minute passing a certain point of some road between 8 am and 10 am on a Sunday. Assume that x has a Poisson distribution with mean 5. Okay. So, mean is lambda in the case of Poisson distribution. So, we are given lambda equal to 5. Find the probability of observing 3 or fewer cars during any given time, okay, during a given minute. So, let us x denotes the number of cars observed, okay, in any given minute. So, this is x is greater than or equal to less than 3 or fewer, less than or equal to 3. Okay. So, we need the probability that x is less than or equal to 3, which is probability that x takes the value 0 plus probability that x takes the value 1 plus probability that x takes the value 2 plus probability that x takes the value 3. Okay. And probability that x takes the value x is equal to e to the power minus lambda, lambda to the power x divided by x factorial we know. Okay. So, when x is 0, it is e to the power minus lambda, when x is equal to 1, it is lambda e to the power minus lambda, then x equal to 2 means lambda square e to the power minus lambda by 2 factorial, then x equal to 3 means lambda cube e to the power minus lambda divided by 3 factorial. Lambda is equal to 5. So, we get e to the power minus 5 1 plus 5 plus 5 square divided by 2 factorial plus 5 cube divided by 3 factorial. When we calculate this, it comes out to be 0.265. Okay. Now, let us go to next question. Given that probability of an accident in an industry is 0.005. Okay. So, P here is 0.005. Assuming that the accidents are independent, determine the probability that in any given period of 400 days there will be an accident one day. Okay. So, number of days, okay, n is equal to 400. Okay. So, n equal to 400 gives lambda equal to, thus lambda we know, lambda equal to n p. Okay. So, 0.005 into 400, which means that this is 5 by 1000 into 400. So, it is 2. Okay. 2. Okay. So, now what is the probability that there are at most 3 days, okay, before that determine the probability that in any given period of 4000 days there will be an accident one day. Okay. So, probability that x equal to 1, okay, there will be an accident one day. Now, lambda equal to 2. So, probability that x equal to 1, probability that x equal to x is e to the power minus lambda, lambda to the power x by x factorial. X here denotes the number of accidents. Okay. So, probability that x equal to 1 means lambda into e to the power minus lambda, lambda is equal to 2. So, we get 2 times e to the power minus 2, and this is 0.271. Now, what is the probability that there are at most 3 days with an accident? Okay. So, probability that x is less than or equal to 3. Okay. Number of days with an accident, x denotes number of days. Here let x denote the number of days with an accident. Okay. So, here there must be at most 3 days with an accident. So, this is p x less than or equal to 3. So, p x so this is sigma x equal to 0 to 3 e to the power minus lambda, lambda to the power x divided by x factorial. Okay. So, lambda is equal to 2. Okay. So, sigma x equal to 0 to 3 e to the power minus 2 to the power x divided by x factorial, and when you put the values of x 0, 1, 2, 3, okay, and find this sum, it is 0.857 we get. Okay. Now, we go to this question. A manufacturer of cotter pins knows that 5% of his product is defective. So, P is 5 by 100, that is 0.05. Okay. Pins are sold in boxes of 100. So, n is equal to 100, and which means lambda is equal to 5, okay, n into p. He guarantees that not more than 10 pills will be defective. Determine the probability that a box will fail to meet the guarantee. The box will fail to meet the guarantee if the number of pins are more than 10. Okay. So, let us x denote the number of pins in a box, then probability that x is greater than 10. Okay. Required probability is that x must be greater than 10, and this is nothing but sigma x equal to 10 to infinity p x equal to x. Okay. So, this can also be written as 1 minus sigma x equal to 0 to 10 p x equal to x, because the total probability is 1. Okay. So, 1 minus sigma x equal to 0 to 10, okay, p x equal to x is e to the power minus lambda, lambda to the power x by x factorial, and this is equal to 1 minus sigma x equal to 0 to 10 e to the power minus lambda. So, e to the power minus 5, okay, 5 to the power x divided by x factorial. When we calculate this, it comes out to be 0.0137. Okay. Now, this is our last example. On an average 1.3 gamma particles per millisecond come out of radioactive substance. Determine mean variance probability of more than 1 gamma particle emitted. Okay. So, let x denote the number of gamma particles. emanating from the substance, okay, particles. Then mean of the Poisson distribution is equal to lambda. So, mean is equal to lambda, and we are given that on average 1.3 gamma particles emanate per millisecond. So, lambda equal to 1.3, and variance is also equal to lambda. Okay. So, variance is also 1.3, okay, in the case of Poisson distribution. Now, probability of more than one gamma particle emanating from the substance we have to find. So, probability that x is greater than 1, which is what we need to find. This is 1 minus probability that x is equal to 0 plus probability that x equal to, okay, x is more than 1. So, x is equal to 0 and x equal to 1, okay. We need to subtract probability of more than one gamma particle, okay. So, this is p 1 minus p x equal to 0. So, e to the power minus lambda and then lambda e to the power minus lambda, okay. So, 1 minus e to the power minus lambda times 1 plus lambda we get. This is 1 minus e to the power minus 1.3 into 2.3, okay. So, the answer will be for the probability of more than one gamma particle emanating from the radioactive substance, probability should be of x greater than 1, and for that we need to subtract the probability of x equal to 0 and probability of x equal to 1 from 1, which means that it is 1 minus minus 1.3 into 2.3. So, this value is the answer of the third part of this question. Okay. So, with that I would like to end my lecture. Thank you very much for your attention.